So very quickly, so once you hit spawn here, you'll actually be placed within the university, and then you can actually hit F to fly out. You can hit F to fly out. Oh, some people are in there. There you go. And then you'll be able to actually go into the loan, if you will, go into the quad. I think that's what we used to call it. We used to call it when we were in college. So yeah, once you go in there, then you'll actually see us. You'll see us live streaming within the metaverse. Hope somebody else is flying in there. All right. So we are recording this session. Thank you all for joining. I'm going to keep an eye on the people that are coming in, and I will hand it over to Justina.
Great, thanks for that, Justin. Do you want to put up the slides so everybody can see?
On to
excellent.
Give me a
so
second.
No problem. I'll give it a moment. Welcome everyone. I still see people coming in.
There we go. All right, we are good.
Excellent.
All right. All right, it's loading up on Zoom now. I think we're ready to go.
Great. So yeah, my name is Justina and this is Justin. I'm the founder of Women in Blockchain Canada. And Justin, you want to also give a brief introduction about yourself?
Yeah, so thanks everyone once again. Justin Golston. I always say in the Web2 world, I'm a professor at Penn State, advisory board member at Georgetown and USC. In the Web3 world, we're actually building a university in the metaverse. So SydTek University, which is where some of you are now, is one of our what we refer to as a satellite campus. So we have SydTek University within CryptoVoxels. I'll let Justina talk about the Women's Center of Excellence she's building out within CryptoVoxels as well. And then we have a number of other builds within CryptoVoxels. Justina, if you follow Justina on LinkedIn, you will see where she's doing a lot of work with the Futurist Conference, and we're actually transitioning over one of our builds to host a lot of presentations within the Futurist Conference. And I think about a month ago, Metallic actually confirmed that he will be speaking at the Futurist Conference, so there's going to be a big turnout. So I'll take it over, hand it back over to you, Justina.
Yeah, Justin, why don't we move to the next slide where people can see where they can reach us. So if you do want to get in touch outside of LinkedIn, if you want to email us, if you want to check out our website, that's our information. And everything that we're going to be presenting in this presentation is not financial advice, it's for educational purposes only. So just to let you know that. And I myself have been working in the blockchain space, doing meetups and events in Ottawa and Montreal and online. So I'm happy to be doing that with the Web3 Foundation and Polkadot. So today, and this is information about us. So I've been doing the meetup since 2019, and I'm working on now building, as Justin mentioned, the Center of Excellence in the metaverse and in CryptoVoxels and hopefully on other metaverses as well. Excited to go to the Futurist Conference next month, and also looking forward to doing more events this year across different universities in North America and Europe. So with that said, Justin, why don't we describe to everyone what we're going to be going through today? I think I read the disclaimer already.
We talked about the non-financial advice. So this is the second presentation in a series of presentations where we're going to review when we're going to go to talk about Polkadot. In the first event, we actually did a presentation at the AIBC conference in Toronto, where we talked about DeFi. So we talked about Akala and Karura within the Polkadot and Kusama ecosystems, respectively, and we're going to touch on DeFi a little bit as well, and we're going to talk about a number of projects within the Polkadot ecosystem. We're going to provide you with an introduction to Polkadot. We're going to first talk about an introduction to blockchain, what blockchain actually is, and Then we're going to go into Polkadot, what separates Polkadot from other blockchains, as well as components of Polkadot. We're also going to talk about staking. So you maybe you've heard of the merge with Ethereum, where they're going from proof of work to proof of stake. Polkadot has always been a proof of stake protocol, and we're going to talk about, instead of just simply earning rewards, what the true utility of staking actually is within the Polkadot ecosystem. We're also going to talk about events such as slashing. We're going to talk about the treasury within Polkadot. There's a lot of opportunities within the Polkadot ecosystem in terms of the treasury. The treasury wants people to build on Polkadot, so there are funds within the treasury where anyone can build. Anyone can build, anyone can educate. And then we're also going to talk about, how we set up a Polkadot wallet, where you actually get DOT and Kusama from for utility. It's not financial advice, for utility. And then we're also going to talk about the differences between Polkadot and Kusama. We're also going to give you an introduction into parachains and para threads. We're going to discuss there was some news that came out last month in terms of Polkadot updating their governance structure. So we're going to go through that. And we're also going to talk about smart contracts, how projects are building, because Polkadot does not have native smart contracts. So we're going to go through the process of that and Ethereum virtual machines, also known as EVMs. And then we're also going to go through WASM and XCM and XCMP. There's a lot of acronyms, but we'll do our best to discuss those acronyms and to also kind of put it into Web 2 terms and scenarios, because you're going to get a number of people within the industry saying that the blockchain is dead. There's really no use case, but a number of organizations are already building on blockchains. You don't even know it. So we're going to go through that, and we're going to say, how our functions are going to transition from the Web 2 world into the Web 3 world.
So thanks for that, Justin. So for those who may not know, I'm just going to do a quick overview of what is the blockchain anyway. So to simplify it, blockchain is a distributed ledger. But what does that really mean? So to give you a metaphor for that, if you went to dinner with 20 of your friends and everybody was having orders for their dinner and you all kept track of it, at the end of the night, if the waiter came and said what you all had, and there was a mistake, you would, because everybody was writing all that information down, you would be able to agree if you agreed with the waiter or not. So it's essentially tracking that is not of information on a ledger that's not in one place and it's distributed, but using a consensus algorithm where in cryptography, the computers agree whether the information is correct or not, and providing security to the network. So we will go through more of that as we go in the presentation, but in simple terms, it's immutable. It's an immutable ledger where because it's distributed in so many places, you would really have to, the security is so good, it will be very difficult to break that security. In fact, right now, blockchain is the most secure database that exists right now. So Justin, I think I gave my intro on the slide.
Thanks all for being here, and we apologize for the delay. We just had a slight technical issue.
All right, I think we got that one. All right, so with the introduction to blockchain, there's a number of projects out there. There's a number of blockchains out there. Whenever people say the blockchain, there is not just one blockchain. There are dozens of different blockchain protocols, dozens of different blockchain projects. Polkadot's just one of them. And the difference between Polkadot and the other blockchains is that the initial plan for Polkadot was it to be interoperable, right? They want to operate between and integrate and message and communicate with different blockchains. So if we talk about if we talk about how Polkadot's going to do that, if you look at this screen on the right hand side at the screenshot, you'll see that web, and that web is the communication streams, if you will, the key to Polkadot. So if you look at this, that round ring, that's what we refer to as a relay chain. We're going to talk about that shortly. And Polkadot, and we're going to talk about layer zeros in the next slide, but Polkadot is a layer 0 where all of those little blocks, all of those little dots in the gray area are parachains. Okay. So each parachain can represent a different blockchain project, if you will. Okay. So initially there were going to be 100 different blockchains on Polkadot, but then Polkadot introduced pair of threads, which we're going to talk about, which lowers the barrier of entry for projects. So, we'll see in the parachain loans where people had to raise hundreds of millions of dollars just to secure a lease, just to lease out that parachain slot. Right. So that's very difficult for some smaller projects. And that's why Polkadot introduced pair of threads, which we're going to talk about. And then you also have things, if you see those lines going out of Polkadot, those are what we refer to as bridges. And that's how Polkadot is going to communicate with different blockchains. That's how Polkadot is going to communicate with Bitcoin. That's how it's going to communicate with Ethereum. Right. So Polkadot was the vision of Dr. Gavin Wood. Gavin Wood was one of the founding team members of Ethereum, and he felt he had visions of where Polkadot was going to go. So whenever Ethereum had a roadmap, and it did not include what Gavin Wood was envisioning, then Gavin Wood went off and created the Web3 Foundation, Parity, and then ultimately Polkadot. So if you want some more history, Gavin Wood branched off and created Polkadot. We also branched off and got Cardano from the founding team members of Ethereum. So these are the pioneers within this Web3 space. And also, Gavin Wood has been identified as coining the term Web3, right? So Gavin Wood is influential within this blockchain space as well as the Web3 space. So whenever we're talking about Web3, we can start with the Web3 tech stack, and starting at the bottom where we refer to as layer zeros. Layer zeros are essentially where we talked about Polkadot. We talk about Kusama, which is a canary network. We're going to talk about that. You also have Cosmos, which people say is a direct competitor to Polkadot. I disagree with that, but more on that shortly. And then you also have Avalanche, where some say Avalanche is a layer 0. And then as you move up from layer zeros to layer ones are your your Bitcoins, the Bitcoin blockchain. The layer ones is the Ethereum blockchain. Now you also see these other two logos, and that's Akala. So Akala is a DeFi platform that we talk about a lot, and Karura is their project on Kusama. So the reason why I included that is that they built on the Polkadot relay chain. They had, so Karura within the Kusama relay chain had a parachain slot, just one of those parachain slots, right, that they built on. Akala had the same thing. They secured a parachain slot to build on with the layer 0, with the layer 1. Now moving from the layer 1, so let's focus on Ethereum as a use case right now. With Ethereum, you have a layer 1. Now, you also have what people refer to as Ethereum killers, but that's where the Optimism comes in, the red logo. That's where the Immutable X comes in. That's where the Polygon comes in. But I disagree with this statement, Ethereum killer, because they're building on Ethereum. They're a layer 2 Ethereum, Ethereum protocol. So they are creating layer 2s so that they can make the transactions cheaper and faster. right? So a lot of people are wondering what's going to happen with some of these layer twos, some of these smaller layer twos when everyone goes to when Ethereum goes to proof of stake. But I think that they have such large communities that these layer twos they're not going to thrive to the level of Ethereum, but they're still going to thrive. So that's where the layer two protocols come in. And then within layer two, on top of layer two protocols, you have layer threes, and that's where our decentralized exchanges will come in. You have Uniswap, which is a unicorn. You have SushiSwap, and then you have Maker, is where users will actually swap tokens, or they will also be liquidity providers. So a lot of people ask the question of, okay, where's all the value come from within a blockchain? And that comes through liquidity providers. You provide liquidity on these protocols, on these threes, for example, and then you get rewards for essentially loaning out your tokens, right? So that provides liquidity to that protocol, provides liquidity to that particular project. And then on top of that, you have these layer fours, where that's where the fox is the logo for MetaMask. So that's where you store your crypto. And then you also have the ship, which is OpenSea, where OpenSea is very popular because that's the market, the NFT marketplace. Now you've seen other NFT marketplaces coming out, such as LooksRare, and those are layer fours as well. So that's essentially the Web3 tech stack, and we'll go a little bit deeper later on, but I don't want to confuse you. So back over to you, Justina.
Thanks, Justin. So basically going back to why Polkadot, why is it different? What does it do in the current ecosystem? So it's, as Justin was saying, it's interoperable. So interoperable, it means it can interact with different blockchains. So essentially, you can have a bridge between Polkadot and Ethereum. The other thing is, so again, like earlier, Justin was saying it's a layer 0. So what does that mean? Well, the relay chain provides, it's a fully sharded blockchain. So what that means is it provides a level of security to the users using the relay chain as a layer 0. And then it has the parachains, which are the layer 1 blockchain. So the reason for that is the different blockchains so you have the internet, right? And then you have different browsers that you can use to get to the internet, like Mozilla, like Firefox, Brave, and Safari. And so what really Polkadot is trying to do is it's trying to be the blockchain of blockchains. So it wants to be interoperable and transferable with other blockchains, but at the same time, what it's trying to do is have parachains that specialize and optimize for what they're built for, whether it's storage, for example, or it's doing decentralized finance. So, but the thing is that those blockchains can then communicate to each other, but they can also communicate to different blockchains that exist out there. The other thing is, because it's a proof of stake blockchain, it's more scalable because the transactions, like I mentioned, are sharded. And then it allows for easy blockchain innovation. So a lot of the time, people who are creating a blockchain need to know how the consensus mechanism is going to work. With Substrate, it's already there. And what people can do is take the information that's pre-written in code and use that code to start their own blockchain. So really what it's providing is a way for you, like building blocks for you to build on, and we're going to get into that later. And it's higher energy efficiency. So blockchains like Ethereum and Bitcoin that are foundational, they use the proof of work algorithm. And so that takes a lot of computational power to solve cryptographic puzzles to keep the blockchain secure. Whereas we're going to talk about the function of DOT being bonded in order to provide security in a chain. And so, yeah, it's secure, it's energy efficient, it's cheap to operate, it's interoperable, and it allows for on-chain governance. So when people wanted to do changes, for example, about the Bitcoin block size and couldn't agree on it, people had to copy the entire Bitcoin code and create a new blockchain And that's called forking. Whereas in this case, you can make on-chain software changes with users agreeing and having a consensus on the voting. So with that being explained, Justin, can you go to the next slide and I can go and introduce Substrate? So Substrate is described as a modular, flexible, extensible framework for building blockchains. But what does that really mean? As I was saying earlier, what it really provides users is like a library of code where they can go in and not start from scratch, because it would take a lot of information and work to start a blockchain from scratch. So if you have code that you can already use to build things and start customizing for whatever you're trying to work on, and you have that existing there, you can just start using it and plug into a system that also offers you that security. So yeah, like it says in the slide here, it gives users components of the blockchain that would take months to build on if they were doing it on their own. So like that's the security component, that's the, whether it's the transferability component, on-chain governance component, all those things are already there. So people can start building further on the specific blockchain that they want with the need and use that it has. So Justin, if you want to go to the next slide, we can go into explaining the Substrate palettes. Go ahead.
Give me a second, there's a little lag here.
Okay, no problem.
A lot of lag, sorry. Do you see the palettes?
Mm-hmm.
Okay. Are you want me to talk about the palettes?
Yeah, go ahead.
Okay. All right. So yeah. So in terms of Substrate, so as we talked about the layers, there's actually two additional layers in terms from a technical perspective. You have what we refer to as Rust. And Rust is the systems level programming language. And on top of Rust, you actually have Substrate, right? And with these palettes are essentially the blockchain frameworks where we can create customized blockchain applications. So in the Web 2 world, you can see these Substrate palettes as templates, if you will. All right. They can also be referred to as SDKs, if you will, from a blockchain perspective. So that allows for a lot of flexibility within the Polkadot and Kusama ecosystems. You'll see that some of these names look a little strange, but some of those are acronyms such as like grandpa and babe, and they provide different utilities that a lot of people in the Web3 space feel that are very important. Now, one of these palettes so with identity, for example, there is one palette called the social recovery palette. And this is some of the research that we're looking to work on. Actually, I mentioned that I see Magnus in the audience. I actually spoke to Magnus about this. But there's a social recovery palette where they've developed a template, if you will, right? Where if you lose your keys, so within the Web3 space, if you lose your keys, your tokens can be lost forever, right? That private key is really the only thing that can recover your information. Now, with the Substrate palette, we think that we can take that social recovery palette a step further, where we can introduce digital inheritance within Web3. Right. So if you have NFTs, so that metaverse land that you're viewing, so that some of you are viewing in, that's an NFT, right? So if I want to give my digital real estate, if you will, to my daughter, then I could use that social recovery palette, and I could have someone. So if I pass, once I pass away, then because I put who I've nominated to have my NFTs, to have the Polkadot, to have the Kusama once I pass, then that's actually on chain, right? And then it's like a digital, a Web3 will and testament, if you will, right? So that's one use case. And then there's a number of different use cases that have been used for these substrate palettes. There's some things that are coming out in terms of voting. Multi-sig is a big thing. It is a big thing within the Web3 space, where you have multiple people to sign a transaction before any kind of assets are unlocked, any kind of tokens are unlocked. And then there's also substrate palettes in turn for staking, as well as democracy. There's a number of palettes, and there's more and more palettes coming out, because people within the Web3 Foundation are issuing out grants for people to add to the substrate palettes to continue to build out the protocol. So another thing I want to discuss in terms of Rust, that bottom layer, is that for any of you that are devs and are trying to get into the Web3 space, Rust would be a language that you could look at, because we say that we're metaverse agnostic, we're blockchain agnostic, right? So because we're blockchain agnostic, Rust is one of those languages that will open the doors, because near protocol, as well as Solana, actually builds on Rust. But then you also have Polkadot as well, as that's building on Rust, and it's one of those languages that are built. It's built for dependability. It's built for speed, right? So as we bring on more of these institutions, right, you're going to need speed to process a number of transactions in a given point in time. That's the biggest issue that we have within the blockchain space right now. It takes a large amount of time to process transactions. Ethereum is looking to solve that with the merge, but Polkadot is one of those blockchains that is already able to process a high number of transactions. Anything else you want to add to that, to the palettes?
Yeah, so to simplify, it's a library of code that people can use to basically do specialized blockchains using the Polkadot, like what's already been created. And then it uses WebAssembly to execute it. So it does on-chain changes which I will discuss later. So it's like it's easy. It makes it easy for you to create a blockchain that connects to that has the security of the relay chain, that gives you the database layer, the networking layer, the consensus engine. And that's just really a library of plugins of things that you want to do. So if you want to have an NFT blockchain that specializes in hosting NFT information, then you can start, like Justin was saying, one uses identity, another uses assets, and you can start building and specializing in that. That's all I have to say for that.
All right, excellent.
So what is the relay chain? So the relay chain is basically the center of the Polkadot ecosystem. So because it's the way that the system works itself is it's distributed, right? Like other blockchains. But the difference here being is that it's a layer 0, and then it has the layer 1s built on top of it. So the transactions are, the way that it works is the relay chain provides everybody the security, but it runs in parallel to the other chains that are running the layer 1 blockchains that are specialized in whatever they're doing. So that allows for faster transaction processing speeds. And DOT can so the actual DOT token, what happens is people stake that DOT token. And so they put forward the collators put forward transactions to be approved. And if they're not acting in accordance with the governance structure, or if they're doing things that are not okay, then they will be punished for that. But the block isn't really completed until it reaches the relay chain. And I believe, Justin, so essentially what is the use of the DOT? Well, it's for governance, for staking and bonding, and we'll go into that a little bit further. And the next slide, I can explain to you the different components in the consensus role. So basically, you have any user can become a nominator and start selecting the validators. So basically, the proof of stake works in a way where people take their DOT and then they bond it. And so that means that because they've bonded this DOT, they're going to most likely behave in a way that serves the ecosystem and not lie, because if they lie, they're going to be punished for that. So people in the ecosystem get to elect, so they are the nominators, because they want to put their, save. It's like a savings. Staking is like saving. So you're putting your DOT away, you're nominating someone to validate these transactions. But because it's sharded, before it gets to the validator, you have these collators that are full nodes. So they're running the entire blockchain, which means they are, so they're collecting the transactions from the users and producing proofs for the validator to, in the end, seal it and put on the relay chain. And so, and also there's fishermen who are monitoring to see if there's any bad actors in the ecosystem, given it's a proof of stake ecosystem. So the way that it works is that if you're putting in your money, you're likely to be want to be honest. Otherwise, people won't nominate you as a validator to do the work of the validator, and you're going to also have financial losses if you do that. So if you go to the next slide, I see someone. We'll get into that. I see there's a question. We will get into how bad actors are punished and slashing. So this is this slide explains the working mechanism essentially. So you have the collators, which aggregate the transactions. Then the transaction moves and the validator actually validates that it's correct. And then the block is added to the actual blockchain. But the way that it is structured is that using Merkle trees, it's so these transactions are hashed to be compressed to be smaller, so the throughput is higher. But the thing is that, so the current issue with the ecosystem is how much transactions can you process per second? In proof of work systems, given there's so many machine solving and how difficult the difficulty of the proofs has become, the transaction speed is now slower. Even on the way that Ethereum's been built, now there's a lot of bidding on the transaction speed using money. Whereas on these kind of systems, you get, because essentially the hashing power is split using the Merkle tree method, which you can prove something's correct and break it down in size and know that this is the truth, even though so it's like essentially it's compressing what you're doing and still having the security piece in it. It allows for the high throughput, but at the same time, it's cheap to operate. So that's why this system is so innovative. And not only that, it can interact with other blockchains. So like, for example, Ethereum right now is trying to move over to a proof of stake system, but they're deciding what kind of proof of stake system are they going to be using. In this case, you need only one collator to run a full node to make sure the security of the ecosystem is correct. Like a lot of people could start, lying, but if you even just have one full node running and keeping all that information, you still maintain the security of your system. And then what really the validator does is just add the next block to the transaction. So it splits up the work, but you're still maintaining the security of the system. So Justin, do you want to go to the next slide?
All right. So we've discussed a lot about Polkadot, but we also have a network called Kusama. So Kusama is what we refer to as a canary network. It's also referred to as a protocol, a test net with value. because Kusama has its own token with value that you use for staking, that you use for nominators and validators. So Kusama was developed to test the limits of Polkadot, but in some cases, it was the value was added to incentivize people to test, as opposed to Rinkeby. So Rinkeby is a test net on Ethereum, right? So you can actually go on a Rinkeby, test out, scenarios and things like that before you actually deploy on the Ethereum mainnet. But within Kusama is where blockchain projects will actually build. They will actually have users interact. They will reward users to test out their protocol before you actually go into Polkadot, right? So we'll talk more about that when we talk about the crowd loans, but to date, most projects own Polkadot. I'm not going to say all. Most projects own Polkadot will begin on Kusama and then move to Polkadot, and then some people, and we're saying that in the future, some R&D type projects, for example, some innovative projects that want to test the limits, they'll actually secure a parachain slot on Kusama and actually stay on Kusama without going to Polkadot. Right, so it just depends on the use case of the project, of whether or not they're going to go from Kusama to Polkadot or just stay on Kusama. Okay, the differences, and then you'll also because these two protocols are within the same ecosystem, if you will, you'll see these two projects referred to as .sama, Polkadot and Kusama, but the differences between the two is that Polkadot has a methodical governance structure. We're gonna go into governance. We're going to go into the version 2 of the Polkadot governance that was just announced last month. Because of the current governance model, the upgrades are a little bit slower because there's a small subset of the technical committee that has to vote on a referenda and things like that. So the current state upgrades are slower. I have to preface that, but with Polkadot, it's more focused on security. Now, the security is very important with Polkadot. Security is very important within the blockchain. And, one thing that's very important is that the larger the decentralized network becomes, the more secure it becomes, because now you have more eyes on these transactions, right? So Polkadot is focused on the security. That's one of the main benefits. That's one of the reasons why a lot of these projects, DeFi projects, go on the Polkadot, because of its security structure. Within Kusama is a little bit looser, for lack of a better term, if you will, in that it has a quicker updated governance structure, because all of these governance structures are tested on Kusama, make adjustments before it gets rolled out into Polkadot. So again, it's very experimental. So the governance structure that they're testing out before they roll out the Polkadot is tested on Kusama first, make adjustments, then roll it out. The upgrades are faster on Kusama because once again, that's the experimental protocol, experimental network, if you will. The parachain deployment is easier and cheaper to deploy, and once again, it's also referred to as live net testing, right? Because you can view Kusama as a live net, but it's still a sandbox for Polkadot. So that is the differences between Polkadot and Kusama. But you would say, okay, why go on Kusama, and why? It depends. Once again, it depends on what the use case is. And in my opinion, looking into the future, I would see that more institutional type organizations may go straight to Polkadot. In some case, I could be wrong. I'm just speculating here. But all those institutional organizations, they're going to end up on Polkadot, in my opinion. right? Where some of these smaller projects, like the pair threads, which we're going to talk about shortly, some of those pair threads may stay on Kusama. Some of those pair threads may go straight to Polkadot. Again, it goes straight to the use case of whether or not you want to go on to whether you're going to go on to Kusama, then Polkadot, straight into Polkadot, or just stay on Kusama. So those are the key differences. And just as at a high level, Kusama is a live test net for Polkadot, so that people are trying to, and again, the motto of Kusama was expect chaos. So they're trying to test the limits before they actually go to the Polkadot live net. Anything else on Polkadot and Kusama you want to add?
No, I think you covered it.
Okay. So you want me to do staking, or you got it? I forgot who was supposed to do this.
I think I can start it and maybe you can help me finish it. So basically, what is staking? Staking is the equivalent of you going to a savings account and putting your money there, but and getting rewarded for keeping your money there. So staking but when it comes to blockchain, what it is putting your money in one place in order for you to validate the transactions on the blockchain and then get a reward for that. So as what I was explaining earlier, as a nominator, you nominate validators and then you end up getting interest on the DOT that you decide to stake. And it varies on the validator that you choose, but you can, because everything's public, you can check who are the validators, what kind of percentages are they giving you for putting your money with them. And then you can decide what kind of rewards you want to have so you have to make your own decision, but it's public for you to view how much percentage you're going to be earning based on the money you're going to be putting in, and what's the history of this person, how have they been validating, did they do any suspicious activity or not, what's their history like, and then you can make your nomination for your validator and start earning interest on the Polkadot that you have. So Justin, what would you like to add?
Yeah, so just to add on to that, so Polkadot does what we refer to as a nominated proof of stake model, and that goes back into what Justina was referring to with the nominators and validators. So that's very important within the Polkadot ecosystem. It's very important within the Web3 space, in that a lot of protocols are looking for ways to further encourage their communities and their holders to actually participate in voting in the future of the protocol. We're going to talk more about that. We're going to talk more about that once we talk about the governance. So I would say I don't know the exact percentage, but a large majority of these people that are staking are looking for rewards. But then those large stakers are actually want to have a voice within the protocol. They have conviction in these protocols. We're not just talking about Polkadot. We're talking about all protocols. They have conviction in the future of those protocols. So they want to acquire those tokens, to stake, to provide referenda, to provide proposals, so that the developers can actually build a solution for this Web3 world. So the biggest thing within that I wanted to share about the staking was the whole nominated proof of stake, where if you're a holder, you can actually nominate other people. If you don't have want to vote, you can actually nominate validators. You can actually nominate people to vote on your behalf and things like that. Just like in the Web2 world with voting and things like that. So a lot of things, if you view it through a Web2 lens, this whole blockchain space isn't really that complicated. Right. So this is one report that came out at the beginning of the month from Masari. Masari is a is a big Web3 research firm. They research a number of different protocols. They just published a report on July 1st talking about the validator stake distribution. So unlike the Web2 world, where you'll have large investors that could potentially hold large percentages of the stock within an organization, the Web3 world and Polkadot's a little bit different in that you'll see a larger distribution, right? So that's where this decentralization is going to be very important, in that you have the voice of the community, right? We talk in the business sense, where we talk about the voice of the customer. You know, in the Web3 space, we get the voice of the community, right? Because if you're a holder, you can issue a proposal, right? And that's why the whole staking is very important. But you'll also see, if we have time, we'll go to a website where we're actually going to go to Subscan. So this actually came from Subscan. So we'll actually go to Subscan and see the amount of DOT that a lot of these validators hold. You know, because some of these validators hold millions of DOT, like literally. You know, so they have weights in this. So individuals can have a lot of weights in this protocol, as opposed to like Zug Capital or Blockdaemon, these large organizations, these billion-dollar organizations, right? It's like Andreessen Horowitz. Andreessen Horowitz, you know, has a lot of say in some of these projects that they were early investors in, right? And if they do not like a proposal that was issued by the community, because they control 15% of the tokens, they can shut down that proposal. One company, right? Where it could lead to the benefit of the community, but because they hold a large portion of the token, because they staked a large portion of the tokens, hypothetically, right? They could vote against that, right? So that's some of the things that we're testing out, that we're looking into within the Web3 space, to understand what's the behavior is going to be, you know, of these VC firms, of these large holders of these tokens, and of the community. So that's just one thing in terms of the staking distribution. And the main thing I wanted to point out is that the staking, the holding, the decisions aren't made by large institutional investors like in the Web2 world in some organizations. It's distributed across a large number of people, a large number of holders within the community. And I think that's very important. It's a whole lot different. It's a whole lot different than what we see in the Web2 world. This is just one screenshot of the Polkadot staking screen. If we have time, we'll actually go in and view some of the mechanics within the staking within Polkadot and Kusama. Anything else?
No, I think we can move into I think people are having a chat regarding you know, what building a parachain and why would you even use Kusama and all this kind of stuff. Well, so just to add here, like there's also parathreads. So parathreads are, if you want to, a parachain, essentially, we're going to go into the parachain auctions a little later. So you have to have a crowd loan, and people have to be in your community, and you have to have an idea, and then you get a slot to have the security of the relay chain and the throughput of the transactions. Whereas a parathread is if you're just starting out and you're bootstrapping a project, but you do want to have the security, but you don't need it as often because you're not running a full blockchain, you can run a parathread. So again, instant connectivity, but it gives you partial volume. So your throughput's not the same, whereas a parachain gives you full security, instant connectivity, and full throughput. So it's kind of like a pay-as-you-go blockchain where you can, you know, be running something that's an experiment. But someone also in the audience asked, well, what if you want to, why would you use Kusama anyway to run experiments? And why wouldn't you just do it directly on the Polkadot ecosystem? Well, I would say that there's a lot, like people make mistakes all the time. Once you run a smart contract and you write the code, it's very difficult to go back. And because you're running on WebAssembly, something I'm going to be going on later, it's like a software update. Think about it. The reason this was built and why it's special is because it makes it easy on your browser for you to be doing complex transactions. So me and you, I can send you something like an NFT. And so you could have just transferred $1 million worth of value. So you don't want there to be mistakes and bugs on that system. And the way that these smart contracts are deployed on Polkadot, because of WebAssembly and the language is so convertible, so there's like, again, there's substrate and then there's WebAssembly. And so given how how connected to the net things are and how quickly you can run things just on your browser, doing things, you wouldn't, in my opinion, you would want to test that before you launch it. Like if you're having a DeFi protocol and now you have a vote and the actual interest people are earning is going to go down, there's huge financial implications these things can have. So people would want to do changes to smart contracts more in an environment where things are more testable. But when you're more fully developed and deployed, you want to be doing it on like the Polkadot ecosystem. When your product is basically like, oh, I'm finished, I'm done testing, I know what I want and I've built it and now it's running smoothly. Because think about it like this, right now, you want to have a software update to your computer, you have to go download it and run it. When it comes to a system, a blockchain like Polkadot, it's done in the browser. Once I've decided to update how my functions are executed, it's done. It's done in real time. That's the beauty of WebAssembly, but that's also like what you have to think about when you're going to be doing updates in that kind of an environment. So, Justin, do you want to go to the next slide? Yeah, so you can see here, so the relay chain has, it's a wheel with different spokes. And now those parachains attach there, but there's also a spot for parathreads, there's a spot for bridges, and I will let Justin help me finish this, the information off on this slide.
Yeah, I liked your analogy to the hub to the hub and spoke model. I'm gonna start using that one. I like that one a lot. But so we briefly talked about this in the relay chain. So as you can see, this is more descriptive, where you can see that the parachain, so you can see the bridge. So the line going out, that's the parachain bridge slot. So that is where we're going to send out transactions. We're going to send out communications to other blockchains, right? And then you also have the collators that we discussed before. We have the validators that we discussed before, but the one thing that we want to discuss is the parathreads. So you can see on the top that we have more validators for the parathreads, because you're going to have a number of blockchain projects within a parathread pool, right? So for example, you'll see that Moonbeam literally raised hundreds of millions of dollars to lease out a parachain slot. A small $10 million organization will not be able to do that. So that's where those parathreads are going to be very important. And another thing is that parathreads are pay as you go, right? So you don't have to rely on crowd loans, to raise hundreds of millions of dollars to lease out the parachain slot. You can just do a pay-as-you-go model with the parathreads, and then you're going to be joining other projects within the parathread pool. On that, yeah. Anything else? You're ready to go to slashing? Yeah.
So I think Adena asked a question, if I'm saying that name correctly, regarding slashing. So like when someone has a misconduct, their funding does get slashed, and depending on the type of misconduct, they can the level of slashing differs. And so, for example, the smaller percentage misconduct is like, isolated cases of unresponsiveness. So you're not being responsive, you're not providing, throughput. So you get a, 0.1% taken away from you. And then otherwise, you can have an outage, unresponsiveness, and it happens consecutively. then you get like a 1%. And then like now, let's say, whoa, there's a something larger, but I think Justin, you can add here, but it's unlikely to happen in good faith or by accident, but it does not lead to a serious security risk, then it's a 10%. But if you're doing anything that poses, you know, anything that was on purpose and poses a security risk, you're just going to get all your money slashed that you bonded. So it depends on like what the kind of issues that are occurring. That's how the funding of the validators will get slashed. Justin, do you want to add something to that?
Yeah, I think that, yeah, it's important to note on Polkadot in that although you may be nominated as a validator, you still have to put up your DOT, right? You have to put up your DOT, you have to put up your KSM, right? And there was a story that one person actually did get slashed, right? So there were malicious acts, and they actually got slashed. But it does not, again, this is consensus based. So it's not just the word of one person to say that there was a malicious act that was occurred. You actually that person brings up this particular act, right? Then the community reviews it, they make a decision, and if that person indeed gets slashed, a portion of that slashed amount goes to the treasury, which we'll talk about shortly. But the person who actually reported the malicious act gets rewarded as well, right? So within these communities, you are incentivized to report malicious acts, but yeah, so the slashing does not occur often within the Polkadot ecosystem, but in other projects, slashing is going to be very interesting. There's one project called BitCountry. If you want to read a case study, you can go to my LinkedIn. We actually published a case study on BitCountry, but they're actually introducing a slashing mechanism where so they're building a metaverse, right? And let's say that someone had said derogatory comments within the metaverse, right? That someone within that ecosystem, within the BitCountry ecosystem, can bring that to the council, right? And within that BitCountry ecosystem, they can get voted on, they can get slashed. They can get a token slashed. Now, in addition to that, you have the BitCountry ecosystem, but then you have what we refer to as sub-DAOs. So decentralized autonomous organizations. So BitCountry will have, so let's think of like a federal government, right? So the federal government has laws, states have laws, munis have laws. The same thing is going to hold true within the Web3 space, within the metaverse space in this particular example. So you can bring a malicious act to the BitCountry, council. You can also have a malicious act for coming up for slashing for the sub-DAO. So let's just say for the individual metaverse, because BitCountry has literally hundreds of metaverses, right? So then you could have within that individual metaverse, you could have a council where you're going to have a slashing issue, and then you could actually go all the way down to the individual community sub DAO for slashing. So slashing can get complex, but it's just there to remove the malicious actors out of the Web3 space, out of these communities. So if any of you have went into Meta's horizon, oh, it's bad. It's bad. Right. So if you were to introduce slashing within Meta's metaverse, yeah, you wouldn't have that many people in there. But I think this is a good thing to keep these environments inclusive and to keep these networks and ecosystems safe. That's all.
Okay. What do we have coming up?
Treasury.
Yes. So the funds from the slashing actually get put towards the treasury. And so what does that mean? So when people want to build things within the ecosystem, so you can see here, the treasury is funded by slashing, transaction fees, staking inefficiency, and parathreads. And then the funding can be used for developing different things that are useful in the ecosystem, such as presentations like this to create awareness. It's also about doing education, but all kinds of different projects. Justin, do you have other ideas of what the Treasury has been doing recently?
No, so in addition to the slashing and transaction fees, I think the biggest thing in my opinion, from a community perspective, for those people on this call, the Treasury is looking to give out DOT. They're looking to issue DOT for grants so that you can actually continue to build within the ecosystem. So within the Treasury, they have what they refer to as a spend period. So they have a spend period of 24 days where they have an allocated number of DOT. KSM the same exact. So Kusama is the same way as Polkadot. Both of them have a pool of funds that they will issue out to build out their ecosystem, to build out their developers, to actually educate and do community building out of the Treasury, right? And anything 1% of the funds that were not spent during that spend period are burnt. So what burning means is that they're pretty much lighting fiat on fire, right? To never be used. So do you think they would rather give someone money to build out their ecosystem, or simply burn it, because for the sake of burning it? So they've already allocated those funds, and they're looking for people to contribute to the ecosystem, and that's one of the biggest things. That's, in my opinion, that's one of the biggest things for that the Treasury is doing, because now you're not only including developers like other protocols, you're including a community, because it's my view that yes, we need to build these protocols, but if people don't use them, what's the point? What's the value of all these great solutions that's getting built out by all these devs that these other treasuries, these other foundations have given all this money to? So giving out. So if you're interested in doing Polkadot meetups, Kusama meetups, Polkadot has those funds in the Treasury to actually do that. If you're interested in that, you can just reach out to us. Anything else?
No, I think that's good. I like you maybe, so yeah, there's a lot of different wallets that you can use. I think, as Justin was mentioning earlier, well, I personally would say the best way to do it is the Polkadot.js extension, because on the desktop, I find it just allows you to have autonomy over, choosing a validator and seeing things. But maybe, Justin, you can go over the other wallets, and then we can get into where people can purchase Polkadot.
Yeah. So for the bullets on the left, so the parity signer, the Polkadot.js desktop, and extensions, those are parity created wallets, right? And on the left-hand side, those are parity created wallets, just to, in my opinion, just to get things out there, to get people to use those tools, because for newer entrants into the Polkadot ecosystem, they can be complicated. They can be overwhelming, right? There's a learning curve to the parity wallets and extensions. On the right-hand side, because they have acknowledged that, they have actually issued out grants to other projects to actually create front-end wallets, more user-friendly front-end wallets. Okay. If we had, doesn't look like we're going to have that much time, but I would check out, if we don't have time to get to it, I would check out Polka Wallet. I would check out Talisman, and I would check out Fearless Wallet. Those some of those. So Polka Wallet is actually a phone app on your phone, and it's actually pretty good. So with these wallets, not only can you store your tokens, but you can also, on some of these wallets, you can all participate in governance. You can also participate in voting. You can also stake within those wallets, right? So yes, you can do that on the parity created wallets as well, but the ones on the right-hand side are incredibly more user-friendly than the parity wallets. And again, parity, or the Web3 Foundation actually funded the creation on most of those wallets on the right-hand side. So we went through, you know, the important, how staking works within the ecosystem. You know, we talked about the wallets. You say, okay, you tell me all about this. How do I get the tokens? How do I get the DOT and the KSM tokens? Now, it's very important to note that there's a lot of people on YouTube, on social media, on IG talking about the be experts. I'm not even an expert, but the two tools that are very important to better understand these tokens is CoinMarketCap and CoinGecko. And what CoinMarketCap and CoinGecko is that they're essentially market aggregators. They provide education in terms of Web3 projects. In some cases, the CoinMarketCap actually gives education and rewards people for learning about blockchain. So sometimes they do have a learn and earn model. But I would, and again, when you ask the question of, okay, which one's the best? You have to look at it for yourself. Same thing with the wallets. Only you can determine which wallet's the best. You know, so for example, in the Ethereum ecosystem, I like MetaMask. Other people like Coinbase and they hate MetaMask. I'm not a fan of the Coinbase wallet, although I use Coinbase. So again, it's all about, you know, your preference. But if you look at CoinMarketCap and CoinGecko, there are currently, I just checked this morning, there are 499 exchanges, which means there's 499 options of where to go and to get to purchase these tokens. Now, of these 499, not a single one of them is going to have all 20,000 tokens there are to offer. Right, so you're going to have some that are on Coinbase. You know, some of you are familiar with Coinbase. You're going to have some that are on Binance. You're going to have some that are on Binance US. So you can see on the left-hand side where Polkadot, you can get Polkadot on Binance. You can also get Polkadot on Binance.us. So Binance.us is the US version of Binance. So some tokens that are on Binance are not on Binance US because of regulation, right? So you're going to get that with some of these tokens. So again, you'll have to do your own research to decide which is the best exchange. Now, for me, like I said before, there's certain exchanges where you can get tokens where you can't get them at other ones. So yes, in some cases I'm on Coinbase. In some cases I'm on Binance.us. In some cases I'm on Kraken. It depends on what the token is. Right, but if you're new to the blockchain space, I would say that I would take a look at Coinbase. The fees on Coinbase are higher, but Coinbase is a good on-ramp to those that are new to the Web3 space and the blockchain space whenever you need to have tokens to participate within the ecosystem. Anything else you want to add?
No, I think it's a good overview. Depending on where you are, the regulations, you will know what exchange you can use to acquire Polkadot tokens. Hold
a minute. Give me a second. Frozen up there for a second. Okay.
Yeah, so now we're going to get into parachain auctions. So what does that mean? So basically they want the foundation wanted the projects to be competitive in terms of ideas and incentivized. So they basically you know, they're already doing community building before they get the slot. So they're doing a crowd loan. So people, you know, give their DOT, so that what that really means is these projects pitch ideas to users, and the users think, oh, this may be a good idea. I'm gonna lock up some of my money for a little bit, and then I can use that. Then what happens is that crowd loan allows them to become part of the relay chain. So it allows them to be a spoke of the wheel. And then it's almost like getting a lease for your blockchain space, and it has to be renewed, but they have time before that gets renewed. So it incentivizes the blockchains to stay competitive, to innovate, to keep upgrading what they're doing. Justin, do you want to go to the next slide where we can get into more of what that actually looks like? So yeah, so here's an example. People have their DOT, then they what the company will do is they'll do the crowd loan. They'll take a snapshot on a particular day on the blockchain to see when you've put your DOT in, and then Justin will go into like the idea of the liquid DOT, because the idea was to have these locked up for 2 years, but a lot of people don't want their funding to be locked up for such a long time. So Justin will go over what that means specifically.
Yeah. So yeah, we can go ahead and talk about that now. So in the slides coming up, you'll see where the time frame to bond your Kusama is a whole lot shorter than what you have to do to bond your Polkadot. So within Polkadot, it's going to you can have your Polkadot bonded for 2 years, right? So as Justina said, people did not want to lock up their DOT for 2 years. So initially, Akala created what they refer to as liquid staking. So within liquid staking, so if I gave 10,000 DOT, I'm just looking at the screen here. If I gave 10,000 DOT, I could stake that DOT. I'll lock that DOT up for 2 years, but then I could have what they refer to as liquid DOT, where liquid DOT essentially creates liquidity for your tokens, your bonded tokens, right? So you can actually reinvest that liquid DOT for further rewards for the crowd loans. We're going to get into the crowd loan rewards shortly, or you can take that liquid DOT and actually loan it out to another DeFi protocol. You can exchange that liquid DOT for a stable coin, you know, and use it for whatever you want to. You can use it to pay your mortgage, whatever you want to use it for. So Akala Parallel Finance did that, which is another tool, another DeFi protocol on Polkadot and Kusama, and then Lido Finance did that as well. So you'll see that done with a lot of these with a lot of the DeFi protocols, where you can lock up your DOT, but then they'll actually give you liquid DOT in exchange. So another thing I want to talk about within this parachain auction example is that it's very interesting. So to mitigate the risk of people, because you have a known date of whenever the winner is going to be announced, so on day 7. So to mitigate the risk of people jumping in at the end of day 7 and putting in a bid of 18,000 DOT like we have on this screen here, there is a randomly selected date and time, a randomly selected snapshot of whoever had the highest bid in that snapshot. They actually win that parachain slot. So in this example here, someone contributed 10,000 DOT. Somebody put in a bid for 10,000 DOT. And because the snapshot was taken midday, day 5, for example, that person that put in the 10,000 DOT actually won the parachain slot, as compared to the person that put in the 18,000 DOT right before the auction ended. Right. So that's one thing that was very innovative in terms of Polkadot, to kind of mitigate the risk of someone trying to game the system, if you will. So in this example here, on how parachain auction slots work, it's important to note that the bonded weeks, like we said before, is different in Kusama as compared to Polkadot. And this is an excellent graphical representation that Kraken. So Kraken's also is a centralized exchange, and within Kraken worked with Akala to participate in the crowd loans. So you could go on to Akala's website and contribute your Kusama, or you could go on a Kraken and contribute your Kusama, right? So in some where you can actually participate in a crowd loan. Some people are more comfortable with keeping their DOT and KSM on centralized exchanges. So that's why Kraken did that for some of these projects. But to run through it really quick, you can deposit deposit your Kusama. In Kraken's case, you could also deposit Bitcoin, Ethereum, Polkadot in addition to Kusama, and then Kraken will actually transfer that to KSM, and then once that's transferred to KSM, then that gets deposited into the Karura. So Karura is Akala's Kusama network, right? So that gets contributed to the Karura crowd loan, right? And if the crowd loan, once Karura won that crowd loan, talking past tense now, because Karura won that crowd loan, then my tokens would have gotten bonded within Kraken or on Akala for 46 to 48 weeks, right? And then at the end of those 48 weeks, let's just say 48 weeks, at the end of those 48 weeks, then those tokens would be returned back to you. Now, you can say, okay, well, am I going to give someone all of my governance tokens to participate in a crowd loan for them to build, right? Well, these projects with the Polkadot ecosystem will incentivize people to contribute to the crowd loan and rewards, right? And because these projects are competing with each other, some people give handsome rewards, right, within their protocol, and those rewards are essentially distributed out. So you could say that they're vested, where you would get 20%. You would get 20% after the 5th week. You would get 25% after the 10th week. You would get certain percentage after X number of weeks, and then once those KSM gets unlocked, then you would get the remainder of the rewards. So that kind of keeps liquidity within those protocols. But that's one of the reasons why these projects contribute to, or some of these projects do crowd loans, because they incentivize the community to actually contribute to the crowd loan and lock up their tokens. Now, as we said before, the process for Akala and Polkadot is exactly the same. The only difference is that you would have to you could bond your DOT for 2 years. You have to lock up your DOT for 2 years. You can't touch your DOT for 2 years. So that's why the liquid staking was introduced, because a lot of people in the community shared their concerns about that. That's why liquid DOT was introduced. And then once again, they provided rewards for the community to lock up the DOT. Okay. So last thing in terms of the parachain slot. So this is Polkadot. So up until July 1st, these are all the projects that have secured parachain slots on the Polkadot. There are many more projects that have secured parachain slots on Kusama, but we're just going to talk about Polkadot here, because what's very important, or very interesting, I should say, is that if you look at Moonbeam, they bonded $35 million alone on Polkadot. I forgot what they raised on Kusama, but they bonded up 35 million of DOT, and then that's roughly 10% of that total supply bonded. But if you look at that note at the top, 11% of the total circulating supply of Polkadot, 11% is locked up in bonding for parachain slots. So that demonstrates the utility of the Kusama and Polkadot tokens. And that shows that, And that's the endless fight that a lot of these projects are having now of, whether or not their tokens are securities. The SEC just identified nine projects that are identified as securities, but you can see that you have utility here where you lock up your tokens so that you can participate within the parachain slot and receive rewards.
Yeah, so basically I'm just gonna talk about what is special about the Polkadot ecosystem and the awareness of the nodes of each other. So right now, the difficulty is the communication amongst the different blockchains, the smart contracts that are occurring, and having just in general that interoperability that we mentioned earlier. And that's the difference between what Polkadot is offering. So currently, for example, let's say if I want to efficiently have a currency that I use, like I have on one chain, but I actually want to use it in a game in another. So how is it possible that that information is passed from one place to another? But it allows you to have the security of the relay chain, and what we described as full nodes. So the thing here that is interesting is what hashing is. And I'm just going to go into a little bit of description of what the Merkle tree is. So in cryptography and computer science, a hash or Merkle tree is essentially a tree which every leaf node is labeled the cryptographic hash or data block, and every node that is not a leaf is called an in node, is labeled with a cryptographic hash of the label of its child nodes. Now that sounds really complicated, but what it really means is, let's say every hash contains, what a hash is a combination of information that spits out a 12 alphanumeric representation of whatever the input was. And why would that be useful? Well, it's like basically compressing information, because you can still prove A and B equal C without computing all that information in detail. So it's just essentially, in simplified terms, the compression of data, and still having the security of that. And so when it comes to if you go further, Justin, if you go to slide 33, so you can see here, let's say I have the top hash or the root hash. It may seem complicated right now, but what I'm just saying is essentially, if you're painting, right, and you have a color that is purple, and purple is the result of actually the combination of two other colors. You know that the input for purple had to be those two other colors, otherwise purple wouldn't be there. So the top hash is just actually the end result, and all the other hashes are just the input of that information. And so to describe that to you, let's say there's a transaction that occurs between A and B, and that equals C. So I send Justin, let's say $5, you know that A sent to B. But now, what if we wanted to make that more complicated? What if I wanted to send I wanted to verify that I had the money in one of my parachains, I went and I entered a parachain auction, and then I had liquid dot, and then I wanted to use that liquid dot in a game. How would I know? How would the blockchain know that I have money here, but I'm trying to use it here? And so what it allows to do is for basically XCM is a communication between the nodes. It's an ability for them to communicate and open a channel using and make sure that, they can say that they're aware of the information happening on one thing and the other, and still provide that security. So Justin, I'm seeing the hash, but I'm not seeing the XCM and then how it relates to the relay chain and how that relates to parachains. And that's Yeah, so here you go. Yeah, I can see it now. So I have a parachain A, which is, let's say, Akala, and then I have parachain B, which is Remark. So that's an NFT platform. And now I want to take, and I'm a user, and I actually would like to understand how these two different blockchains can communicate between each other using this interaction protocol. And what it is like they open up a channel that's a two-way communication mechanism to verify that these smart contracts are actually occurring throughout these different blockchains. And so the interesting part using this mechanism, it speeds up the communication amongst the blockchain. So the whole point of the interoperability is that you can be using a game and it's optimized to know information from your other accounts. And as a user, you won't even see it because it's using WebAssembly, and what you're actually seeing on the end screen is one thing, but in the back end, all this other stuff is happening. So really the point of Polkadot is so that people can be specialized, but then at the end, it can all work as a whole. So yeah, that's a really cool thing that the blockchains communicate amongst each other. Right now, if you're using Ethereum and you have money somewhere else, you can't really do that. You will the way that it works is different. And so let's say people build Polygon, yes, it allows you to be much faster, but at the same time, you're losing the security. So Ethereum is still working on how do we maintain security and make our transactions faster, whereas Polkadot's already figured it out. It already has the system sharded so that people specialize here on all the transactions and then get the security from the relay chain. And then we're in the, yeah, so we can move forward from that, Justin. I think I'm done with the description of what that does.
Okay. So we're getting down to, getting close to the finish line. So just very quickly on governance, we briefly talked about governance, but so current state governance, Polkadot governance V1 is where Polkadot has what they refer to as a tricameral system, where they have the council, and what the council is made up of 13 rotating members that are voted on to make decisions. So the council proposes referenda. They will also veto malicious attacks. They also handle all of the executive type decision making within the Polkadot ecosystem. And once again, that's rotating members. The technical committee is made up of three active developers within the Polkadot ecosystem, and they do all of the upgrade timelines. They ensure that all of the timelines within Polkadot and Kusama are keeping on track. So, and then you finally have the dot holders that can propose a referenda and voting. But so for a while, that was how Polkadot operated. It worked, but again, Gavin Wood last month said he had some concerns about the current state of the governance, in that the governance process is slow, and that once a proposal is issued, it could take 2 months from proposal, the initial proposal to actually getting that proposal active and getting work to begin on that process. So 2 months is extremely a long time. You could only do one referenda at a time within the current state. So it was clunky, it was long, and then the current state is centralized. Although there were a number of dot holders, a lot of dot holders, the ultimate decision is in the hands of 16 people, three technical committee members and 13 rotating council members. right? So essentially, if someone issued a proposal where a majority of those 16 people didn't agree, they could vote it down. So I guess I'll get to that point in V2. But so that was some of the issues that they were looking to solve. And to answer Magnus's question, they are going to Polkadot V2. So Gavin actually announced this at Polkadot Decoded last month. So to take some of the power away from the council and the technical committee, they are moving that and that voting to what they refer to as a Polkadot fellowship. So it's a larger pool of individuals. So that's going to make it more decentralized. So Magnus, to answer your question, yes, it's going to be pivoting toward hybrid. Even Gavin Wood said that there's still going to be centralized functions of Polkadot, but the ultimate goal, the long-term goal, is to make everything decentralized. Now a number of, and this is one term I use often in terms when we're talking about DAOs, and that's decentralized. That's progressive decentralization, and I'm a fan of progressive decentralization because if you have too many cooks in the kitchen initially, then you're going to have problems. And I like the way that Polkadot is doing this. They're taking their time to have this progressive decentralization model. And Magnus, to your point, yes, right now, current state, once V2 runs out, gets rolled out, it's going to be moving more toward a hybrid. You could argue that they have a hybrid approach now, right? But it's more of a hybrid approach, right? It's more of it's leaning more toward decentralization, right? Its current state is more heavy on the centralized side, but that the V2 is moving further toward decentralization. And they want to make this V2, make the governance structure more inclusive. And what they mean by that is that instead of having one referenda at a time, you can have multiple referenda running at the same time, which means that you'll be able to get more votes or get more referenda through and processed than now, right? So that's what they're talking about for in terms of inclusivity, because now more people have a vote, and that's going to increase the number of decisions within the network. And then one thing that is interesting is this multi-role delegate system. So what this multi-role delegate system is that for those people that are holding large amounts of DOT, once again, they have people that have 1 million DOT, right? They can, so yes, we're moving over to the Polkadot fellowship, but within the multi-role delegate system, if you're a large holder and you want to give more say, you want the council and the technical committee to have more say, right? Because you have trusted those people, because you have voted the people in the council in, because the technical committee are the people that's been there, in most cases has been there since the beginning, and they understand Polkadot inside and out, you may want to give those people more power. So then that's multi-role delegate system will allow you, if you don't want to vote on the referenda or on the proposals and things like that, then you can take your voting power and give it over to back to the technical committee and the council. Now, I think there's mixed thoughts in terms of that, but again, and so this governance V2 model will. So this goes back to your questions. This governance model will start out in Kusama. It will get tested in Kusama, and then Polkadot will evaluate any changes that need to be made before it gets rolled into the Polkadot ecosystem. Okay. Now, two things really quickly that remain unchanged within the governance model that I think is very important is referred to as conviction voting. One thing I'm a big fan of is that, so conviction voting says the longer you held your DOT, the more say you have, right? So again, some people disagree with that, right? But if you have supported the project since the beginning, my opinion, these are views of Justin Golston, I feel you should have more say. You understand the development since the beginning, you understand the protocol, you understand in most cases, you understand the technical aspects of it. So that's one thing that's, so the conviction voting is one thing that's unchanged from a Polkadot perspective.
So I'm going to go over Polkadot and smart contracts. So let's start with the definition of what is a smart contract. It's essentially code that is a piece of code that executes on the it's essentially a code that executes when certain conditions are met. So to give you an example, let's say I'm transferring a land title. Right now, you need lawyers. You need to check in the system if the land or the title belong to a particular individual. And then once a lawyer oversees this, the deed or the title is transferred to another person. Well, with smart contracts, the smart contract would actually go and fetch that information on the database, see if it's true, and if it is true, then it will execute. So let's say A is sending a simple, the simplest form of smart contract I can describe is, let's say I wanted to send $5 to a friend of mine, then the smart contract on Bitcoin, like really the first one you can have is it makes sure that that money goes from A to B and it's executed. Or in decentralized finance, it makes sure that you have the funding for you to invest your DOT and save it or to stake it. So smart contracts are just pieces of code that execute when certain conditions are met. And so, in this slide, as you can see, that includes DeFi. A smart contract can be, I'm moving an NFT from one wallet to another. That's another form of smart contract. So for example, today, all of you can provide us with your wallets and we can send you an NFT for attending this event. And then that will also be an execution of smart contract. It's saying that you were here, you gave us your information, and then that transfer then occurs from our wallet to your wallet. And you will, and you can receive that. And it also, there's going to be, I think smart contracts are amazing. They're not exactly like a regular contract, as in there's so many variations of it that you can have, but you can use it in legal cases as well. And that eliminates for the use of a trusted third party, such as a lawyer. And that's the beauty of it, but also it can really help to allocate funds in the future for things that are necessary. And like we were describing earlier here, like, having fair voting, or like, let's say a country does a census, you can actually see the information on the transparent ledger, the blockchain, and then it can help policymakers distribute the funding afterwards for places that need it the most. And so I think with things like AI coming in, with things like where we can get the information that's decentralized and faster, we can use smart contracts to really solve a lot of the problems we're facing currently in society. But as it stands, for example, Unique Network, I interviewed them while we were in Texas at Consensus, and they, for example, saw that a lot of these more expensive NFT are difficult for regular users to procure, so they fractionalize your ability to buy NFTs. And then you have the participation. So other things, I'll give one last example. Another use of that could be, well, if 80 people wanted to buy one house, they could. That's something that cannot happen today without the use of a blockchain and without the use of smart contracts. So with that being said, crowdfunding will be a big thing. And then the last slide we have, I'm going to go over what is EVM and what is WebAssembly. So essentially, what I was trying to explain earlier is like we are all using browsers, and then smart contracts are being executed in the back end. But the thing is, you're all using computers, and that computer is running bytecode, so it can process transactions. But given the blockchain doesn't really live anywhere other than the virtual space, these are essentially virtual machines. And what that really means is like what we mentioned earlier is the nodes. The nodes are storing the information. So it's storage on different machines. And then when these smart contracts are put out and executed, there's a state from A to B. So ownership, like let's say I own a piece of NFT and then it's going to go to you. At the end, there's a change in the blockchain, but the transaction that happened was the NFT went from A to B. So what the EVM does, or what WebAssembly does, is as a user, you don't see it, but in the backend, it shows the transition and it uses bytecode. So it compresses the information of that smart contract. So it doesn't take such a long time to execute. So with Ethereum, every single smart contract is just like run on the EVM, but because WebAssembly makes things even run faster on the browser, and because Polkadot wanted to be the internet of blockchains, and they wanted to, the blockchains to be interoperable, they already built it within WebAssembly. So WebAssembly also converts, like it can use C++, C, or Rust, right? And then WebAssembly, like as a user, what you end up seeing is a simplified form of what's happening with the operations in the back. So it's like, for example, if I want to have a game that's more robust, but I want to run it in the browser, what it allows you to do is just see that final product with really quick runtime in your browser. And so the state in the back of like the execution of the smart contracts can happen a lot faster. And also because of, so all of these things were done to make this ecosystem run fast and be secure. So what you end up as a user, you don't really see what's happening. You see the NFT in your wallet within seconds, but in the back end, it's the smart contract execution. It's a blockchain execution. It's going from A to B. And the beauty of it is like what can't be done on other networks and can be done on Polkadot with the speed that it's doing is that I can also like imagine you're able to be in the metaverse and use your tokens from another blockchain with this blockchain. Like that's what I was saying with XCMP, because the communication is all happening in the back end, but also it's all running in WebAssembly, that's what was made to make browsers more efficient in the first place. So I think it's really cool what they did. I also think like, it's compatible with Ethereum. So it's not like there's a maximalism here. I think what I also like about Polkadot is that people can migrate and have one thing in one place and then use it in another. So until Ethereum catches up, and I'm sure that they're going to, I think it's really cool that people can migrate over as well. I see there's also questions coming up. I think they both allow I'm not really too familiar with Atom, but what I can say is that people can build blockchains from scratch using basically the substrate palettes that we described earlier. So any developer can go in and start, putting a blockchain together and then adding the specifics they want once they've done the research. So to answer your question, maybe Justin can help me out here, but personally, from what I know is that it's not really difficult to build a blockchain. What the difficulty will arise when you want to start customizing things. And so then you will need your development team to work on that. But in terms of like the security aspect and like the identity aspect and things like that, that's already there. You can use that. In terms of making it, customized for your specific purpose, you would need to work on that. And I can give an example of that after, but Justin, what are your thoughts?
I think it ultimately depends on the project. I mean, a lot of these use cases depends on the project. So for example, in some cases, if you have a large scale NFT project, some people will argue, I'm never going to do an NFT project on Solana. I'm never going to do an NFT project on Polkadot, because all the community is in, hypothetically, all the community is on Ethereum, right? I think it ultimately depends on the project. Like, so for example, if there was a palette that did not exist in Polkadot, where you would have to create the blockchain from scratch, you could actually propose that to the Web3 Foundation. The Web3 Foundation may be able, if you want it to be open source, then the Web3 Foundation would actually fund it for you, so you could actually build it, right? But if you had a proprietary solution, for example, then maybe Cosmos would be the answer for it. If you needed an interoperable proprietary solution, Cosmos may be. I would have to assess what that project would be. But so we just spoke with Moonbeam. So Moonbeam, Moonbeam was the first parachain to go live on Polkadot. Now they're integrating with Cosmos, right? So it's that true interoperability. And so you have a project that started on Polkadot, and now they're integrating with, they're staying on Polkadot, but they're just increasing their reach into the Cosmos ecosystem. So again, I just think that it depends on the project. I hope that helped. Didn't really answer your question, but I hope it helped.
Yeah, so Git is what Ethereum uses, and I see Adam's using Git as well. And it's just like a conversion, like it's basically making the code like run faster because it's bite-sized. So like I see also Adam is written in JavaScript. So I can't really comment. I'm gonna have to do my research on this. But from what I see, it's Adam is written using JavaScript, and embedded Git control developed by GitHub. So again, it is designed for browsers, but everything still even if it is JavaScript, it has to run through like WebAssembly, like WASM. It all has to go, like it still gets converted. I'm not sure how that changes the rate of transactions or things. That's something I'll have to look at. But Git is also what the Ethereum virtual machine uses for things like what Justin was explaining earlier in that slide, where it says like layer 0, layer 1, layer 2, layer 3, layer 4. What does that mean? Well, I'm using a MetaMask wallet and it's connected to my browser, but I'm doing the transaction on Ethereum of swapping and going onto OpenSea, connecting to that, and then being able to do the transaction in the back end. But so I have to figure out how that affects the runtime. And then what that really means is that JavaScript still has to be like it's either Git or WebAssembly, one or the other, but I will have to look more into how that's run. But the idea is the same. Like it's just a virtual machine for executing smart contracts that makes it fast because you're going from frame to frame to frame. So it's like, what it really is I'm taking a snapshot of the blockchain now and now and now and now. And what it's doing is it's making it optimized for you to see it on your browser as a user to say A went to B, but you're not, as a user, what you're really looking for is how fast is this going? How secure is it, right? And right now with Ethereum, it's expensive and you have the security, but it's expensive. With Adam, I'm gonna have to go and test it out and see how it works and see what applications have built on it. So thank you for bringing that up for us. And for those who would like to get a NFT from us today, please provide us with your Ethereum or Kusama address so we can send you the NFT.
Yep. So thank you for that, Elizabeth. Yeah, so if you have any questions, that's pretty much all we had. We don't really have time to go through setting up a wallet. We're going to actually create separate short videos on that, on how to create a KSM wallet. But if you want, if you have an ETH address, you can go on. You can actually Google. Go on YouTube and type in MetaMask. And then you could actually get a MetaMask wallet where you'll actually get an Ethereum address that you could send. But if you have questions, send me a message. We'll walk through it. I'll send you some links on how to set up a wallet since we're out of time, and we'll get you an NFT.
Thank you everybody for joining us today. And hope to see you at our next event. We are doing an event on July 30th in Montreal. If you can't attend in person, we'll be live streaming it as well. So make sure to tune into that. We can look to, you know, adding the questions that you guys have into our next tutorial. So it can be more robust. We really value your input. And yeah, we will make sure to keep a copy of these questions.
Yep. All right. I'm just answering questions now.
Excellent, great. So yeah, why don't we, I took a screenshot of all the questions, Justin, as well.
Okay.
So we can have it, and then we can drop the information, like when we drop the YouTube, like we can send you the other videos of like setting up the wallet, and so you can provide us with your address as well. There's already videos that exist for that. We'll be recording our own, but we can definitely, if you scan the QR code, I think that's a good start on your mobile device. And then if you download an app called MetaMask, that would be a good first start. And then what we'll do is, right when we post this video, we will post videos underneath it, you know, here's a video on setting up your wallet, here's a video on how to provide us with your address. Is that good, Justin?
Yep. So yeah, if you have any questions, just reach out to me. Just find me on LinkedIn. Find me on LinkedIn. You could also
yeah, follow us.
Put your Twitter on in the chat.
Yeah, follow us
in this DM, and then we'll help you out.
I think the best thing will be for us to post these answers for those who don't know these things right on the YouTube, so that it's there for everyone, you know, and then everybody can use it. So we took a screenshot of these questions because they're very useful, and then we can address it to a larger audience.
Magnus said, "Don't leak our ETH addresses." Will not do. Will not share your email information or your ETH information.
Sounds good. Thank you, everyone.
All right. Thank you, everyone. I know this was long. We ran over a little bit. That was a long session, longer than I thought it was going to be. And Justin was, you have it on record. Justin was right on that one. But yeah, so thank you for staying on. And if you have any questions, just reach out to us on LinkedIn or on Twitter. Thanks again.
Thank you. Bye-bye.
Bye-bye.